My name is Ethan Tapper. I'm the Chittenden County Forester. And for those of you who don't know me or don't know what a county forester is here in Vermont, we're about 75, 76% forested. 80% of those lands are privately owned. And so a big part of what county foresters do is we help landowners manage their private forested land. And so what that means is that we manage this tax abatement program called the Current Use Program, where landowners with acreages larger than 25 acres enroll in the program, and they agree not to subdivide or develop their land, and they follow a forest management plan, which is approved by and monitored by the county foresters. That's a big part of our time. We also visit landowners with parcels of forested land of any size and advise them on how to be a good land steward and manage their land responsibly. We also manage town forests, municipally owned forested land in our counties. And then the last part is we're just sort of trying to answer this question of how we elevate the health of forests and the quality of forest management in our county. And that's where I get to do sort of this creative stuff like what we're doing right now. So tree ID as part of that is really, really important. And the reason for that is because we're not managing for, plantations like they do maybe in the American Southeast or in the Northwest. We're managing for diverse forests comprised of many different tree species. And Vermont has about 50 native tree species, and we want to grow them all. And they all behave differently. They all have different attributes. And so to be an educated, informed landowner who manages, a parcel of land of any size, and to be able to interact with the literature that we have, you have to know what trees you have. And then just as sort of a person who enjoys forest, it's also really important because you can go from when you're out in the woods, like I know many of us are finding a walk in the woods to be a welcome escape from our homes at this time. When you're out in the woods, it turns an area that's just trees into sugar maple and red oak and white pine, and really just enriches your understanding of the forest. And so in that way, I think it's also really, really important. We have a couple co-sponsors here who are really amazing partners who I work with all the time. Lisa Sawsville is here from Vermont Coverts. Vermont Coverts is an organization that helps landowners manage their land responsibly and particularly emphasizes peer-to-peer learning between landowners. If you want to make a donation to Vermont Coverts, you can visit their website, which Lisa will type in the chat box, and support them in that way. They also have an amazing training program that they do, 2 to 3 day training program. They usually do twice a year. This year it will be in the fall. And Vermont Woodlands Association, Kathleen Warner is also here from Vermont Woodlands Association, also the American Tree Farm System. And you can support the American Tree Farm System by donating to them or by becoming a member. And they do all these amazing educational events. And the American Tree Farm System is this storied, really amazing system of parcels of forested land that are managed really well. And so support those two organizations, please. If you want to be connected to future opportunities to learn about stuff like this, you can get on all of our e-news lists. So I have an email list, as does Kathleen, as does Lisa. And we are trying to put on events to educate landowners about how to be good land stewards all the time. And so get on those lists and you'll be kept in the loop. And so the way that we're going to manage this program tonight is that, obviously when I took this class, it was a semester long class, dendrology, and we had 7-hour-long labs every week, and it was this really involved process. And I'm just going to kind of try to expose you to a primer on that, and based on most of the trees that are the most common in Vermont. So there will be more to learn, but I'll try to get you started. Everybody will be muted for the duration of the presentation. If you have a question, there will be a short question and answer section or session at the end of the presentation. Please type your questions or comments into the group chat, which you can find on my PC here. There's a bar at the bottom of the screen. There's a little chat icon. I guess in Macs, it's up in the upper right-hand corner of the screen. And you can type your questions in there and we'll answer as many of them as we can after the presentation. So with that, Kathleen, are we recording?
Yes.
Great, so I am gonna get started. All right, so again, this is focused on Vermont and identifying our most common trees and giving you some tips and tools to do that. These are trees that are also common in other northeastern states, but in different proportions. So it will be admittedly a Vermont-centric picture. Let's see if I can get it to change. There you go. So one of the problems with identifying tree species, if you just go out with an identification book, is that you're given too many options. And so these are the top 10 tree species, most common tree species by number in Vermont, and they account for 85% of all the trees in the state. So if you learn these 10 tree species, you've learned 85% of the trees you're gonna see. So those proportions will change. There's other parts of the state, you know, little pockets that will have other tree species in abundance, but these will be most of the tree species that you're going to see. So, you know, the other 40 native species of trees we have combined account for the remaining 15% of all the trees we have. So it's also, when I was taught this, I was taught it basically based on you need to know every minute attribute of every tree species. And I also think that that's not true. So for you as a landowner, as someone who identifies trees, you don't need to know what the seed and the bud and the bark and the leaves and everything else looks like of every tree species. You just need to know how to identify them. And sometimes it only takes a single characteristic to get you there. And so this book, A Beginner's Guide to Recognizing Trees of the Northeast, it's my favorite tree identification book. And the concept is just sort of right in line with that. The idea is that the author, Mark Mikolas, went to his friends who were raised knowing what different tree species were, as they were taught by their parents or whatever. He said that they didn't identify tree species, they recognized them. And so he tried to drill down with them, how do you know that it is that tree species? Because they would just say, he would say, how do you know that's a sugar maple? And they would say, oh, because it looks like a sugar maple, right? But in reality, it's much more complicated. They were picking up on certain characteristics that were cueing them into what it was. They weren't identifying them, they just recognized them. And so he sort of broke down those big charismatic characteristics over less different species of trees to try and give a more realistic tool to identify tree species. I also like the book Bark by Michael Wotek. So here's some terminology. Leaves can be serrated. You're looking at a yellow birch leaf, that's a serrated leaf. And what that means is that the edge of the leaf looks sort of ragged like that, serrated like a serrated knife. That is a lobed leaf. So a leaf that is lobed has many large obtrusions like that, and sinuses, those are the gaps between the lobes. A leaf can also be toothed. So it's not ragged all around the margin of the leaf. It has these teeth. This is a beech leaf. These teeth that sort of at regular intervals come out around the margin of the leaf. A leaf can be simple. That's a leaf that we're all familiar with. It looks like a leaf. It's one piece. A leaf can also be compound. This is an ash leaf, and while you see multiple leaflets, what look like multiple leaves, this is actually one compound leaf with multiple parts. So we call that a compound leaf. And this is just sort of terminology that you'll use when you're identifying trees in general. A lot of basic tree identification courses really stress this opposite branching versus alternate branching. And what they mean is that either the leaves come off directly opposed from one another on a twig, or they come off staggered on the twig. If it's staggered, it's called alternate branching. If it's opposite, if they're opposite one another on the twig, it's opposite branching. That's a good characteristic in some cases. And of our native tree species, only maple and ash will be opposite branched. The problem is when you're identifying tree species, unless they're very young or you have access to a twig, you're not always able to use that characteristic. So it's only used, but it's not necessarily the one that will get you there to identification. When you get into shrubs and other stuff like that, the rules get a little bit more complicated because there are more ones that are opposite branched. So just as far as terminology, as an FYI, you'll often hear tree species talked about as hardwoods versus softwoods. Hardwoods are deciduous trees. With all these rules, there's always examples of when it's not the case. Like I'll be like, maple will always do this. This is always true. And then someone always says, well, what about that maple? And of course, it's breaking the rule. But for the most part, hardwoods are deciduous trees. They are broadleaf trees. They lose their leaves in the wintertime. They're also in a group called angiosperms, which just means that they're flowering plants. Softwoods are coniferous trees, trees with needles, trees that do not lose their leaves in the wintertime, mostly. There are exceptions to both of these rules. They're gymnosperms, which are also called non-flowering plants. So we're going to start with the most common species of hardwoods. I'm going to cruise right through these because we only have a certain amount of time. Then we're going to go through our most common softwoods. If we have time, we'll go to some of our most common invasive species, invasive exotic plants. I doubt we will, but if we have time, we will. So starting off with sugar maple. So sugar maple, most populous tree by number in the state. Also the state tree, also probably the most economically important tree for a bunch of different reasons. Its bark, to my eye, is a brownish gray. When it's young, starting when it's young, it will always be rough. It has a sort of warty appearance. It will never be shaggy. And this is one of the characteristics that will differentiate sugar maple from red maple, which many people confuse it with. And those are the two most popular species of maples in the state. So the bark will be rough, but not shaggy. When it gets older, it will break up into vertical plates sometimes. It can have this whitewashed appearance. So what you're looking at on is a sugar maple trunk, and on the left side of that trunk, you see this, it looks like someone just sort of slapped some white paint on one side of the tree. That's a really good sugar maple characteristic, and sometimes when you're looking out through the woods, you can see that whitewashed appearance all up and down many of these different trees, and that's a good indication that it's a sugar maple. Buds and twigs. So a lot of times when we're identifying trees, you can't get totally hung up on the leaves, which many people do, because we don't have the leaves half the year. So it's good to have some other characteristics that you can use that aren't leaves. And so what we learn in forestry school is we learn buds and bark mostly. And the buds of every tree are really interesting. If you've never looked at them before, they're really pretty. And an interesting new thing to check out on trees. Right now, many of these buds are getting swollen and preparing to break. But they will develop new buds by about midsummer. So sugar maple twigs are brown, they're speckled white, and they have a terminal bud, and a terminal bud is the bud at the end of the twig that looks to me like a bishop's hat. It's this long, pointy, brown bud. You'll also see that it is, because it's a maple, it's opposite branch, so those two lateral buds below the terminal bud are opposite the twig from one another. And the twig is sort of that beautiful nut brown. The leaves are lobed. They have basically 5 major points, like a 5-pointed star. Between the points, you'll see there's some minor points, but the margin of the leaf is not serrated. So it's actually smooth between each one of those points. And interestingly, so sugar maples, their state tree, it's something we're all very proud of. In many cases, the maple leaf symbology that you'll see on people's logos and stuff is actually a Norway maple leaf, which is a state-listed noxious weed, because they will often have a more ornate looking leaf with many more points on it, and it just looks fancier. But this is what a sugar maple leaf looks like. It's about 5 major points. The margin between the points is not serrated. Now, you can identify this tree in some specific cases because it was retained as what we call a wolf tree in the woods in many cases. So in the 1800s, about 80% of our landscape was cleared for pasture, but they retained sugar maple trees to sugar and to be shade trees. And so what happens when you do that is that they develop this really weird growth characteristics where they'll branch out laterally with big arms to the side instead of, because there's nothing competing with them, instead of reaching up, which is what trees growing in the forest do. And so if you see these trees that are growing like this in the woods, most of the time it's a sugar maple tree. And this is my little sugar maple wolf tree montage. They're amazing looking trees, really, really important for wildlife. That's actually a selfie that I set on a timer that I had to lean it up against a tree and then go run and jump in the crotch of that maple. That's probably the second biggest sugar maple in the state in Williston. All right, so the one that people confuse sugar maple with the most is red maple. So red maple, when it's young, will have perfectly smooth bluish gray bark. So that's a comparison to sugar maple, where when it's young, that bark is that brownish gray and it's always going to be rough. As a red maple gets older, it will become very shaggy and rough. So the bark, unlike sugar maple, the bark will never be shaggy, and you should never be able to pop a piece of bark off from a sugar maple tree. Red maple, you can often do that. And you can often just sort of pull off, the bark's a lot thinner, and you pull off pieces of bark. With many of these trees, if you want to see what the bark looks like when it was a younger tree and you're looking at the bark lower down the tree and it looks shaggy and you can't really tell, look up, because the bark higher in the tree is younger. And so you'll see that very, very smooth bluish gray bark up higher in the tree. The bark will also sometimes have something called perennial target canker, and you'll see the accentuations of bullseyes in the bark, which in this picture here, it's hard to illustrate, but you'll see the accentuations of sort of these partial bullseyes in the way that the bark is broken up. That's just an example of how shaggy and loose that red maple bark gets. So in comparison to sugar maple has those brown twigs with those pointy terminal buds. Red maple has these round red buds and really red twigs. And in many cases, in the wintertime, you'll see actually clusters of buds at the tips of the ends of the twigs. And if you look up in the tree, it'll look like the tips of the twigs have been dipped in wax. There'll be these big bulges at the end of the twigs. And in the wintertime, that's actually a really good characteristic for identifying red maple. The leaves, in contrast to sugar maple, instead of having 5 major points, the leaves have 3 major points, and you can see that the whole margin of the leaf is serrated. So whereas sugar maple was smooth in between those minor points, this is rough all the way around the leaf. And that's actually a much better characteristic than what most people use for red maple, is just the serrated margin. If you have a leaf, you can just tell it's red maple just by that. So just sort of about general features of these two different tree species. You can tap them both, and they are both widely tapped. But they're really about as different as two tree species could be. Sugar maple can live hundreds of years long and become massive. Red maple usually averages closer to 80 to 100 years. Sugar maple, we usually say, is endemic to enriched, especially calcium-rich soils. Red maple can grow just about anywhere. So it grows in old fields, it grows in swamps, it grows on acidic soil with like oak and beech, thin soil, all different kinds of places. Red maple it's what we call like a mid-tolerant tree species, so it's not totally tolerant of shade, but it can tolerate a little bit of shade. Sugar maple is what we call a shade-tolerant species, so it really needs to grow in the shade. They both have, the wood produces really beautiful wood and great firewood. Sugar maple is a little bit higher BTU, and the wood's a little bit more valuable, but I think they're both really pretty. Red maple has a lookalike, which is silver maple. If you see a tree that looks like a red maple and it's planted in someone's yard, or if it's in a floodplain by a big river, it's probably a silver maple. Much less common though. White ash. So there's a couple characteristics with white ash, but the characteristic that you'll notice that'll sort of smack you in the face and be the thing that you look for once you get to know it is the bark. The bark is very, very distinctive. It has these thin, sinuous, interlocking ridges, which are completely symmetrical all the way around the tree. So with most of these tree species, if you look at red maple or sugar maple, the bark will not be symmetrical. It'll be one side of the tree will look different than the other side of the tree. It won't have a specific sort of pattern to it. It'll be doing sort of the same kind of thing, but in different ways. Whereas white ash, the bark will be the same all the way around the tree. And it's these thin vertical ridges that, to me, they look like these interlocking diamonds. The bark coloring is light. It's a whitish to yellowish gray. And I always say that ash has fat fingers. And the reason for that is because ash has a compound leaf. So it has, instead of having little fine twigs, it has essentially a twig that's built into its leaf. So its leaf is a stem with a bunch of little leaflets on it. And so if you look up from the bottom of an ash tree and you compare the size of their twigs to the twigs of the species all around it, you'll see that it's way thick. The twigs are way thicker than any other species. And they're opposite branched. And because the twigs are so thick, it's really easy to see that. And so once you see this, you'll never unsee it, and you'll be able to tell an ash from a million miles away when they don't have their leaves on, which is that their twigs look like an old radial antenna. And so what it is that it'll be that fat central stem, and then those lateral twigs coming off opposite one another at this exact 45-degree angle. You can tell it a mile away. And it just looks, the twigs compared to any other species, it just looks, they look fat and clumsy and really, really different. The terminal bud, so again, that's the bud at the end of the twig. I always used to say that it looks like Jughead's hat. It looks like that weird crown that Jughead wears in the Archie comics. Someone recently told me that it looks like a chocolate chip, and I think that that's probably actually a better tool for identifying it. So the leaves are compound. To all the world, this looks like a bunch of little leaves. But in the reality, what you'll see is that there will be a little bud at the end of this whole leaf. So where this whole leaf meets the stem, there'll be a little bud, and there won't be a bud at the base of each one of these little leaflets. So it'll have 5 to 7 leaflets. And because it has a lot of these little leaflets, I don't know, there's something about it. I think this picture captures it. If you look up in the canopy, you'll see all these little tiny leaves blowing in the surface of, or in the overstory of an area with a lot of ash in it. And it looks jungly to me. It looks like bamboo or something. A lot of times you'll see this tree growing in the woods. You won't see any branches down low. You'll just see branches way up at the top of the tree. All right, white birch. So this is a species that many of you probably already know, right? It's the one species that many of us can identify from a million miles away. When I teach white birch, I will tell you other characteristics about it, but the bark is white and it peels off in these big, broad, papery sheets, and usually that's all you need. These other characteristics of it are not nearly as distinctive as the fact that it's bright white and its bark peels off in these big sheets. Also called paper birch. Because of those big sheets of bark that look like sheets of paper. The leaf is serrated, sort of non-distinctive. The twigs, if you run your fingers along the twigs, they sometimes feel warty or sandpapery. And as far as where they're growing, how they're growing, you'll see that they usually only have leaves on the very top of the tree. And when you see that with a tree species, you can infer how tolerant that tree species is of shade. So tree species that can deal with growing in the shade will usually have branches all the way to the ground. And tree species which are intolerant of shade, we call our intolerance, they will only have tree species at the top of the tree. Or I'm sorry, they will only have branches at the top of the tree. And that's because the growth strategy of these tree species is different. So some tree species like paper birch, like our aspens or poplars, they are designed to grow very quickly and not to live a long time, but to grow in these sort of larger openings. And what you'll see is that if you have white birch, paper birch, aspen, poplar, same thing, in your forest, it usually means that there was a big opening sometime in the history of that forest. Maybe it came from logging, maybe it came from a hurricane or some other natural disturbance event, but if you have white birch in your woods, it means that at some point there was a whole lot of light in those woods. I should say about white birch too, an old white birch is like 60 to 80 years old. They grow really fast and they die back just as fast. This is another tree species that is distinctive. Another birch, yellow birch. The bark is golden and metallic. It peels, but it doesn't peel in those broad sheets like paper birch. It peels in these little thin strips. And so those of you who have used the bark of white birch, paper birch, to start a fire would see that you might try to do it with this one, but you would not be successful. Like white birch, it has these horizontal dashes in the bark. Those are lenticels. They're all you need to know about that is that basically it looks like horizontal dashes in the bark. But the distinctive thing about this one, again, is just its bark. It's golden, it's peely in these little shreds. You're not gonna miss it. That's what it looks like when it's young, very metallic. It can be like a little bit coppery in color. The buds are born on these things called spur shoots. You might recognize them from like apple trees. And all it is these little sort of stubby half twigs. And you'll look up in the top of the tree and it'll look like a tree has a million little teeny tiny twigs, and what they are is these spur shoots. This is another characteristic that you often don't have to use, but it's kind of interesting. If you don't know what a little seedling is and you don't have any bark because it's so tiny, you can scratch it and sniff it, and this one will smell like wintergreen. So that's a very distinctive characteristic. A lot of times, especially with a lot of the birches and hopcorn beams and the cherries, the twigs can all look similar, and you can do this scratch and sniff, and if it smells like wintergreen, it's yellow birch. It also tastes like wintergreen, and it can be kind of nice to chew on when you're walking through the woods. Those are the leaves. They're serrated. They're not super distinctive in and of themselves. The seeds are born in these structures that look like cones. And so they're these, what they really are is they're these bunches of seeds that look like they're in the shape of these little sort of bird's feet. And you'll see them up in the top of the tree in the wintertime. And they look for all the world like cones, like a cone that you'd find in like a pine tree or something like that. But they'll break apart over the course of the winter, and those seeds are designed to be dispersed over the surface of the snow. And that's what one seed looks like. It's teeny tiny, maybe a quarter of an inch in length. They also do this other really cool thing. I say that they do dance moves. And so one thing that you can infer from the presence of yellow birch in your woods in many cases is that they really like to grow on areas with disturbed soil, and they really like to grow on dead wood. And so in the event of a natural disturbance or a logging job or something like that, both of those things are often created in abundance. And so little yellow birch seedlings will seed onto stumps or onto pieces of dead wood. And then gradually over time, they'll put their roots down around the sides of those pieces of dead wood into the ground. The stump or the log will rot away, and then you're left with a yellow birch that looks like this, like it has legs. If you have a lot of yellow birch in your woods that are all about the same size, especially if they're doing this, you can infer that, let's say that all those yellow birch trees are about 30 years old. There was probably a logging job in your forest 30 years ago. It's actually a really good sort of shorthand for telling a little bit about the history of your woods. American beech, excuse me. American beech prior to European settlement was our most common tree species. It was about, depending on where you were in New England, about 40 to 60% of the total forest cover. It doesn't really grow like that anymore, and I'll tell you why in just a second. Healthy beech has bark that I learned as elephant skin. It's this perfectly smooth bark. People carve their initials in it, and you can see them. I've seen initials that have been carved in the 70s, and you can still make them out. This just very, very smooth gray elephant skin bark. Unfortunately, beech is afflicted with a disease called beech bark disease, actually a disease complex. It's exotic. It's not from here. It was introduced in the early part of the 1900s. And it changes the way their bark looks. So a lot of bark that you'll see actually looks more like this. It's pockmarked, black, cracked. Sometimes it'll have this white woolly stuff on it. Those are the scale insects that are part of the disease complex. Sometimes a sort of reddish hue, which is the fungus that is also part of that disease complex. In many cases, sadly, this is what more beech bark looks like. The buds are the longest, pointiest buds you're ever going to see. Hold on one second. The buds are the longest, pointiest buds you're ever going to see. I learned them. I had this amazing tree identification dendrology teacher named John Shane at UVM, and he would say that these look like a cigar that a mouse would smoke. So it's these teeny little pointy buds. They even look like, you can sort of see like the wrappings of the leaf on that. It looks like a little cigar. And there is no other bud that you're going to find in the woods that is that long and that pointy. So it's really, really, really distinctive. The leaves are also distinctive. You'll notice that each leaf vein on that leaf, there is one tooth at the end of each vein. So it's perfect. There's no other leaf that does that you're going to see. So you'll see there's a central vein which runs down the middle of the leaf, and then all those lateral veins, each one vein ends in one tooth on the margin of the leaf. Beech trees produce beech nuts. Beech nuts are an incredibly important mast, so just an edible nut that's enjoyed by basically all of our native species of wildlife, especially by bears. Bears will sometimes climb up in the top of these beech trees and create what's called a bear nest. So they'll get up in the top of the tree and just break all the branches of the tree into the center as they eat the beech nuts off them, and it looks like a giant bird's nest. That's what they look like when they're green, and then they open up into these really cool little 4-compartment seeds. So that's sort of the empty seed hole. Bears do love these tree species, and so that's what it looks like when a tree has been used again and again, climbed by bears. That's what we call a bear-clawed beech. And if you deal with beech a lot, you'll see that it doesn't always make sense which trees have the bear claws. So sometimes there's one beech tree that looks really healthy that you would think the bears would want to climb, that would have more nuts, and it won't have any bear claws on it. And then there's these trees that are just completely covered in these claw marks, and sometimes they're pretty sad-looking trees. People who have done research on this know that these trees are what are called, or what I would call, culturally important bear trees. So they're trees that bears return to again and again. They teach their cubs to climb on them, and they also just visit them. So they'll just visit them and walk around these culturally important trees, which is just fascinating. Another characteristic in the wintertime that you guys have probably all seen this in your woods, these smaller beech trees that are in the understory of the forest, they'll hang on to their leaves. And so they become this sort of yellowish, brownish blur in the understory of the forest, and they will rattle. So you'll be walking through the woods in the winter and you'll hear this little rattling sound, and it will be these leaves from these younger beech trees. That's a great characteristic, very diagnostic for young beech. Before we move on, just quickly, so again, like I said, beech was our most populous tree species prior to European settlement. For a bunch of different reasons. It's a long-lived species. It's a very shade-tolerant species, so it can grow almost completely in the shade. And so there weren't a lot of big disturbances on our landscape, regular big disturbances, prior to European settlement. And so what happens is that species like beech that can live a long time and hang out in the shade, they just sort of hang out in the understory of the forest. All the other tree species can grow faster, but they can't live as long. And so as those tree species die out, beech over time moves up into the overstory of the forest. So when we created these huge open areas, as we did in the 1800s for sheep pasture mostly, and maintained them as open land, as we did in many cases for 100 or 150 years, it's not very good habitat for beech. And to sort of put the nail in the coffin comes beech bark disease, which totally changes the way that they grow. And most beech trees can no longer become those massive ancient trees that they used to. And so they have become, in many cases in forestry, they are considered sort of a weed species because they grow up and they're always unhealthy. They get this disease, they die, and then they shoot up these root sprouts. So that when beech trees are stressed out, they shoot up clones, little sprouts from their root system. And because most beech trees get beech bark disease, they're stressed out all the time. And so they're always shooting up these clones. And then in addition, in most of New England, we have an overpopulation of white-tailed deer. Deer like to eat all of our other tree species, and they don't like to eat beech. So the combination of those two things can create an understory where it's hard to get anything but beech. And so it's just, its role in our forest has really, really changed over time. So this isn't one that's on our top 10 species, but it's locally abundant in Chittenden County and in the Champlain Valley, and also in the Connecticut River Valley of Vermont and other areas with sandy or drier, warmer sites. So I wanted to mention it as well. Northern red oak. When people in Vermont most parts of the Northeast talk about oak, they're talking about northern red oak. We have other species of oak, but red oak in Vermont is by far the most populous. So the bark is, to my eye, sort of a bluish chrome gray. What you'll see in the woods is often you'll be struck by, it's a darker shade of gray than many of the other trees adjacent to it in the woods. And the bark breaks up into these vertical ridges. I've heard them referred to as ski trail bark because it looks, the way that they join one another and split off from one another, looks like when you're looking at the side of a mountain where there's a ski area. I've also heard them described as sanded off ridges. So it's like all these fine ridges came out of the trunk of the oak tree and then they were sanded off, and you'll see that the top end of each one of these ridges has a nice smooth sanded off appearance. Between those ridges, you'll often see a little line in the bottom of that crack. You'll see a little line of red or orange. And you can even see this is a blurry, a worse picture, a blurry picture of a young red oak, which is showing that as that bark stretches, as the tree grows, the cracks that it makes in the bark will be this orangish, reddish color. And when they're young, especially, the bark will be this chrome gray and it will be shiny. And it's very, very distinctive looking once you get an eye for it. The buds, they're pointy. They look a little bit like sugar maple buds, but they're clustered at the end of the twig. So you'll see numerous pointy buds, usually 3 to 4, clustered at the end of each twig. And the leaves are probably what most of you know. So they're these leaves with many lobes and many deep rounded sinuses. So again, sinuses are just the area between the lobes. And each one of those lobes where they stick out, they end in a little pointy tip. They end in what's called a little falcate hair. And they just end in a little point. And so if you were to hold that sideways, it would look like waves, or it would look like a flame or something like that. Some people remember it that way because it's red oak and red like fire, and the edge of the leaves look like flames. They may be shiny. They have leaves which are what's called polymorphic, so they can take different appearances where they are in the tree. So leaves lower in the tree are called shade leaves, and they will be in general broader. They'll be less lobed, and they'll be thinner and less shiny. They'll be sort of finer, more delicate. At the top of the tree, there'll be these deep sinuses in the leaves, and they'll be really rough and thick and shiny, but they will always maintain this same general shape. And they have acorns. So that's a pretty good characteristic. Acorns are amazing. They're not produced every year, so it's not a trait that you can necessarily rely on. But if you're kicking around the bottom of an oak tree, usually there'll be some acorn caps or some old acorns that'll be down there. Northern red oaks are one of our species that is what's called a mast tree species like beech. Many of these mast tree species, they do not produce their seed every year. It's theorized that the reason for that is because if they were to produce a lot of seed every year, everything benefits from a big year with a lot of acorns. So there's a lot of squirrels that eat them, and turkeys and deer and bear and everything else. And the population of all those species is actually buoyed by a lot of mast in the woods. And so what would happen if you just produced a ton of mast every year is that very quickly the populations of squirrels and everything else would rise, and they'd be able to eat all those acorns, and so you wouldn't get to grow any little oak trees. And so what they do instead will be they will starve the predators of their seed for a number of years. In the case of northern red oak, they will only have a mast year every 2 to 3 years. And then they'll produce this bumper crop, and they'll overwhelm the remaining predators of their seed. Even so, and I should say that they also coordinate this over huge areas. So we think by a combination of different things, including chemical pheromone signals, all the oaks over these massive geographic areas will all decide, nope, not a mast year again. And then they'll all decide this is a mast year, and all produce acorns all at once, which makes the effect of this periodic masting more pronounced. I would also say that even with that, for an acorn to become an oak tree, it has a hard row to hoe. And the reason for that is because they're just eaten by and parasitized by everything. So only 50% of the acorns ever get off the tree. Once they're on the ground, 98% of them are eaten before they get a chance to sprout. And so it still the numbers are not in red oak's favor. But when they do get a chance to sprout, those acorns are this amazing energy packet. And basically little red oak seedlings don't have to photosynthesize or produce any of their own energy for years, and they're just feeding off the energy in that acorn. It's pretty amazing. All right, so now getting into some softwood species, remembering that softwoods is just what we call conifers. So any tree species that makes cones that has needles. And I'm just going through the most common ones in Vermont. So this is a very important tree species. It's one of our most common tree species. Much more relatively common now than it was at the time of European settlement, although early surveys of New England really stressed the abundance and the size of white pine trees. And the reason for that is because settlers, colonists were coming from Europe, where they were basically timber starved, and they were looking for resources, primarily naval resources. They need large trees to make into masts for naval vessels. And so they came and they saw these massive white pine trees, and they were just like, eureka, you know, this is this amazing resource. Now, you know, at that time, it was growing in probably very specific areas, sandy sites, along our major, here in Vermont, it would be along our major rivers, places like that. Now it has a different growth strategy that I'll explain in just a second. Its bark, broken up again into vertical ridges, which take on this brownish to sort of purplish brownish color. When it's young, it'll be sort of a metallic green. It branches in whorls, so that's W-H-O-R-L-S, whorls, which just means that every year, about once a year, every year it will put one circle of branches around its stem. And actually, if you can count the number of whorls, and you can see here in this picture, there's 1, 2, 3, 4 whorls, you can know how old a pine tree is. It has these long, slender needles, very distinctive. You know, they're of all the needles that we're going to talk about, these are the ones that actually look like a sewing needle because they're very long, very thin, very slender. They're in bunches called fascicles, bunches of 5. And you can remember that because it's W-H-I-T-E, white, has 5 letters, and there's 5 needles per bunch. When they're at the top of the tree, and you'll see this especially compared to some other conifers, because they have all these delicate needles in such profusion, it'll have this sort of fluffy-like appearance or cloud-like appearance where you'll be able to identify them from the highway. Very distinctive. White pine trees, sort of in their natural, the natural way that they grow, will often grow as a single stem, growing, you know, just sort of with branches at the very top of the tree, but then this sort of smooth gun barrel single stem all the way down to the ground. Now, they don't grow that way as regularly anymore. And the reason for that is because the abundance of white pine today is more likely attributable to the fact that they are really good at, for a bunch of different reasons, they're really good at growing in fields. And we created a lot of good white pine habitat when we basically clear cut all of New England for sheep pasture in the 1800s. Many of the white pine trees we have now are not growing on a site which is actually what we might call, what foresters might call a good white pine site, a site where white pine will be successful long term. They're just growing in the site of an old field. And so you'll end up with these dense sort of monochromatic, monolithic white pine stands. And all that tells you about that site is that it was the site of an old field. And they'll often be growing not as a single straight stem, but as what we call a cabbage pine or an old field pine, bully pine. So that's like the one that you're seeing in the picture there, where it's sort of like you try and cut it down and it takes you like a whole weekend to just dispose of all the branches from that tree. The reason for that is because there's a native insect called the white pine weevil. The white pine weevil, if pine trees are growing in the open, as they are when they're colonizing an old field, the white pine weevil will lay eggs in that top bud. That's the bud that grows upwards and tells the tree to grow upwards. It'll kill that top bud, and more than one lateral bud will go outwards and assume the role of being the new terminal bud. And so that's how you get, those will all develop into these separate stems, and so that's how you get these sort of octopus look like white pine trees. So if you see trees that are doing that, it means that they were grown, at least initially, in the open. And in many cases, again, denotes an old field. White pine trees that are grown in the woods usually do not get attacked by the white pine weevil. And then, of course, they got pine cones. So they've got these long, 5 to 7 inch long, somewhat cylindrical cones, which are the carriers of their seed. Eastern hemlock. Eastern hemlock, prior to European settlement, was probably our second most populous tree species. Another really, really long-lived, shade-tolerant tree species. Hemlock loves growing in the shade. Its bark is brown, and I know that I sort of have used the word brown or a qualifier for the word brown for probably every one of these barks, but the bark of hemlock compared to these other trees is really, really brown. It's not grayish brown, it's not bluish brown, it's just brown. And it's in these vertical plates, which will look a little bit chippy like that. It looks like you could pop chips off. Usually you can't, but it looks sort of flaky or chippy. One of the things that's really interesting about hemlock from an identification standpoint as compared to the other conifers is that all the conifers are very regular. So everything is symmetrical. They're growing in a completely symmetrical way. Their branches are growing in whorls. Their twigs are all branching out symmetrically. Hemlock is the opposite of that. Hemlock is growing completely asymmetrically, completely irregularly. The twigs are growing on top of twigs, and the branches are growing on top of other branches, and the needles are growing on top of other needles. They have these little flat needles, slightly tapered at the tip, maybe, half an inch, 3/4 of an inch long. And it is all about chaos and not about order in the case of how this tree grows. You can also, and that's what they look like on the underside, they have these little white stripes called stomatal bands. They have little round cones that are maybe, 3/8 of an inch, half an inch long. You can identify hemlock in many cases. My teacher, John Shane, would call, when you look into a hemlock woods, he would call it the purple haze. It looks completely different because they're allelopathic, which just means they inject chemicals into the soil that prevent the growth of other tree species. And they create a really, really shaded environment that no other tree species can grow in. And so there'll be these dense, dark stands where nothing else is growing in the understory, and except for hemlock, because they're the only thing that's tolerant enough of shade to grow in the understory there. They need almost no direct sunlight. They're a pretty amazing species in that way. And so in many cases, when you walk into a hemlock forest, a hemlock stand, you'll know it because suddenly it'll get like dark and it'll get quiet, and you'll be able to see through the understory of the forest because there won't be that much growing in the understory. And you can identify it that way really, really well. And if you look out through the trees, it looks like purple haze. It looks like this sort of purplish coloration, sort of that shaded appearance on the trunks of those trees. So now there's two other conifers that I want to talk about. Spruce. So there's 3 different species of spruce that are the most common. In my part of the state, there's actually an additional 2 species that are more common up in the Northeast Kingdom. The one that I usually see in the woods, that's the most common in Vermont, is red spruce. Red spruce is a species which grows from the top of mountains all the way down into some of our upland forests. All the spruce species have this purplish black bark with these little round chips coming off it. These really chippy, round, purplish, blackish bark. That is common to all of them. They also, the moniker is that spiky spruce. They also all have these really spiky needles. They're short, like half an inch long, a little bit different between the different species of spruce, but they're all super, super spiky. If you were to grab the branch, it would like spike you. And the needles are not flat. They're actually angular in cross section. And the way that you can just test that, grab a needle and you can roll it between your fingers. Many of the other needles, you can't do that because they're flat. They branch in whorls. The appearance of the tree looks sort of rugged, severe looking, I would say, spiky and compact. So that's the red spruce. That's the spruce tree you're going to see in our woods the most. There's another species that's planted widely ornamentally, and you will see it in the woods sometimes, because especially in the 30s and the 40s with the Civilian Conservation Corps, this was widely planted into these conifer plantations. It's called Norway spruce. The dominant tree of the Black Forest in Germany, European spruce tree. And still, these plantations remain in many areas, or remnants of them. The characteristic that you can always identify Norway spruce by is that it has pendulous branches. So pendulous branches means that the twigs are hanging off the branches. It looks like the tree's melting. And so you can tell this from, like, if you're in a residential area, you can tell it from a mile away. It's just so obvious, those really, really defined pendulous branches. And you can see them in the woods too. They'll just be less likely to be branches all the way down to the ground. They have these really big cones that look like that animal that I can never remember the name of. What's it called? A pangolin. It looks like the shell of a pangolin, which is an armadillo-looking animal from Asia or from Africa. And it's about, they're about, I would say, 5 to 7 inches long. And they look like the counterweights on a grandfather clock. And the reason for that is actually because many grandfather clocks traditionally came from the Black Forest region of Germany, and they actually designed those counterweights to sort of be the shape of these cones. The cones are very, very, very distinctive. So again, you'll see this ornamentally. You'll see it planted in plantations in the woods, but it's not actually a native tree species. And then the other one you'll see is this species, which I do not like very much, but I guess other people do because it's planted everywhere, blue spruce. And you'll know what it is because it's that incredible bright blue foliage. Still spiky, still severe looking, but bright, bright blue. Okay, lastly, I think we're doing pretty good here. So our last most common conifer in Vermont is balsam fir. So balsam fir and red spruce, especially up in the Northeast Kingdom and on the tops of our mountains, grow together in a forest type that's called spruce fir. They're almost sort of referred to as two parts of the same thing. They're actually really, really different. Red spruce is a much longer lived tree species. Balsam fir is a much shorter lived tree species. They have some other interesting sort of point and counterpoint attributes. But to tell them apart specifically, it's really easy if you have a needle, because the needles of spruce are flat, or the needles of fir, I'm sorry, are flat. So you can remember spiky spruce, you can roll the needles between your fingers. Friendly fir or flat fir. The needles are attached to the twig with one of my favorite vocabulary words ever, which is a suborbicular leaf cushion, which just means a little suction cup. And they are longer than the needles of hemlock, probably about 3/4 of an inch long. The bark is also very distinctive. So the bark is this mottled gray, lighter gray color. It can also appear pretty shiny and metallic, and it's covered in these pitch blisters. These pitch blisters are really interesting. People used to commercially collect spruce gum, which is just hardened spruce pitch that people would chew like chewing gum. And they also used to collect fir pitch, and they would take these little tin cups on the end of sticks and pop all these little fir blisters on the bark of a fir tree, collect that, and they would use it to glue together lenses for microscopes and stuff like that, because it is an adhesive that dries very, very clear. It's also antiseptic. Native people used to use it on wounds. It also, if you put it on the end of a little stick and you put your little stick in a puddle, it will make it move around the puddle like a little motorboat, if you're into trying stuff like that. The cones you will rarely see. They'll be way up at the top of the tree, but they're actually borne upright. So instead of all the other cones of all the other conifers, they'll be hanging down. These fir cones, they're sealed with pitch. You can see they look really cool, but they're standing upright on the boughs of the fir tree. We do not see these very much where I'm from in Chittenden County, because they're more of a boreal species. As you get up into colder parts of the state, up in the kingdom, it becomes much, much more common. The place where I honestly see them the most, either the tops of mountains or old abandoned Christmas tree farms, which we have a lot of. And this is also the tree species that will be your Christmas tree in most cases. with a lot of these conifers, once you get a hang of it, you can actually identify them by profile. And the profile of fir trees is very, very distinctive. They make these really steep, pointy, thin steeples, I call them. So compared to spruce, spruce will be much more of a rounded top. Fir will be this really, really severe, pointy, thin steeple. And with that, I think that I am going to have to end this presentation, and I would love to take some of your questions.
Hey, Ethan, we do have a few questions that have been put into the chat box. I'm going to do them kind of by species. So we first had some about beech.
Yeah.
Should beech with the beech bark disease be harvested for firewood?
They could be. I mean, you know, it's you couldn't harvest all the beech trees even if you wanted to, because there's a lot of them. But on my land, you know, what I'll do is I'll actually look for healthy beech trees. So beech trees that still have that pretty smooth bark, they are somewhat resistant or at least resilient to beech bark disease. And so I will often cut diseased beech trees and leave the healthier ones. I would say that, you know, many, especially even a larger tree, a larger beech tree, even if it has some markings of beech bark disease, it will still often be like an important mass producer. So unless it's crowding out another tree species that is really healthy and doing really well and that you really want to encourage, I wouldn't necessarily harvest it just because it's a beech tree and just because it has beech bark disease. But in general, if I see a beech tree that does not have beech bark disease, there's no way I'm harvesting it. If it still has that smooth elephant skin bark, I'm going to keep it no matter what, because I want to grow our next generation of disease-resistant, healthy beech trees.
All righty. Also on the beech, why does it seem that the beech trees hold on to their leaves? Why the young ones?
I don't know. They just do. I don't know. I'm not totally sure. I know that I read somewhere that the reason for we think that the reason for the smooth bark on beech is that it's a relatively, you know, many thousands of years, I'm sure, holdover from a tropical genus. And that smooth bark is an adaptation on tropical trees that is beneficial because it prevents epiphytes from growing on you. Epiphytes are the many plants in these tropical regions that will grow on the bark of other trees. And it can be harmful to the trees to do that. So that's why they have the smooth bark. And maybe, you know, and because they're a younger tree species, it could be that they just haven't totally figured out how to drop their leaves in the wintertime. That would be my guess, but I'm not totally sure.
All right. The next question dealt with ash. What are the best ways to identify white versus green?
That is so hard. So there's some really minute characteristics, but what I normally tell people to do is to identify it by location. So green ash is the ash tree that you're going to see in almost every case planted. So it's all over the place. It's planted on all of our streets. You know, it's these ornamental trees. That is almost 100% of the time going to be a green ash. Green ash in our woods grows in floodplains, so alongside big rivers like the Lamoille and the Winooski, in the flat areas on either side of the river. And it grows in some other parts in the Champlain Valley in these swamps. So it'll grow and also in Grand Isle County, it'll grow in these swamps with really, really wet soils. So that's how I would identify it. As far as characteristics, there's some very minute bud characteristics and leaf characteristics, but that's how I would do it.
All right. Now we're moving on to oak.
Yeah.
Why is white oak so much less prevalent in our area than red oak? Are we at the edge of their range, or are they not as tolerant of some of the soils?
We are at the edge of their range. And so there are actually in the white oak group, there are 3 species of oak that I often see. So there's white oak, Quercus alba, swamp white oak, which is Quercus macrocarpa, and then bur oak, which is Quercus bicolor. Swamp white oak and bur oak look very, very similar. They are actually both white oak species that live more in the Champlain Valley and are associated with this type of forest that we call like Champlain Valley clay plain forest, which is not very common because most of the really nice flat clay plains in the Champlain Valley are agriculture now. White oak is very different. So it'll grow on very warm sites It'll grow on south-facing slopes, sandy, dry soils. And I think we are on the northern edge of its range. That's part of it. It's also as hard as it is for red oak to grow from acorns, because those acorns are such a treat for every species of wildlife. White oak is even more highly valued by wildlife because its acorns have many less tannins. So they're more digestible, they're easier to eat, they taste better, they're sweeter, and they're even more targeted when they're young by browsing animals like deer than red oak is. And so I think it's a combination of all those things.
Great. Another question, someone wanted to know if the trees on UVM's green, if they're Norway spruce.
I know that there are Norway spruce on UVM's green for sure. Yeah. It's kind of an interesting tree to plant in many of those cases. A lot of these conifers, like blue spruce, I just don't think is a very good looking tree, but many of these conifers like Norway spruce, they get really tall. And so it's not the sort of species that you would think you would really want to plant in a place like that, but many people did. And I think it's because of that pendulous appearance. It just looks nice.
Great. Okay, there's another question that someone would ask that you explain a little more about the hemlock putting something into the soil to keep other species away.
Well, so hemlocks actually do that in a couple different ways. And so many tree species are allelopathic, many plant species are allelopathic in some way. And all that means is that they are they're putting chemicals into the soil that are in some way altering their environment. And that's supposed to make it, in many cases, to compete below ground in the same way that they compete above ground, to make it easier for them to grow and to inhibit the growth of other species that are going to be competing with them. Hemlocks just do that more than other species, and I can't get into the biochemical realities of what that chemical actually is and how it actually inhibits the growth of other species, but I know that it's more of an influence in the case of hemlocks than with many other species. Another common allelopathic tree that you may know about is black walnut. Black walnut has a chemical called juglone, and so if you've ever seen a black walnut or tried to plant something under a black walnut, it's almost impossible to make anything grow. With eastern hemlock, it's a combination of that chemical, and then also through their needles over time, they will also acidify the soil. So they make a very, very acidic soil, which many other species cannot tolerate as well. And then finally, the way that they're also altering their environment is by making it really, really shady. So getting these really dense stands with these incredibly compact, tightly knit canopies, which virtually no other species except for hemlock can grow in.
All right. Someone notes that they have some branches that they thought were speckled alder, but from their presentation, they might be yellow birch. Is speckled alder common in Vermont?
Yeah, speckled alder is what we call a small tree. It almost will be growing like a shrub sometimes. Very, very distinctive terminal buds. They look like boxing gloves. They're red, and they just look like a bulging boxing glove. So if you've got that, you'll probably have speckled alder. It won't be ever very big. I think maybe 15 feet tall, maybe 2 or 3 inches in diameter maximum, and it'll be growing exclusively in wetland areas. But if it's fresh, you can scratch and sniff it, and if it smells like wintergreen, it's yellow birch.
That's a good thing. All right. Logan asks, due to global warming, are we expecting to see more or less of the same kinds of trees, white oak, hickory, et cetera, over time? And if so, are there ideas to get ahead of this from a management perspective?
Yeah, so we expect that the growing conditions will become more suitable to some of our more southern species that were on the northern end of the range. So in the Champlain Valley, this means, and most of Vermont actually, this means oak, this means hickory. We would just expect to see those species more. And there's some species that were sort of, like on the very northern edge of the range, like black gum and some of those other species that we would expect to become more predominant over time. The problem is that it takes a really long time for those changes to actually become affected across the landscape. So trees move really, really slowly. So when we're talking about these certain tree species becoming more prominent, we expect it to happen over a long period of time. There are some foresters that are doing, and forest scientists that are doing experiments on assisted migration and what we can do to sort of make that process happen sooner, and to other ways to sort of lessen the stress of our native tree species. You know, I do a lot of management work where it's for many different reasons, but also for climate change resilience, I would say. We're trying to make our forests more diverse intentionally. So we're actually going in there and we're harvesting trees to try and create disturbances, to try and create opportunities for regeneration, and making our forests more diverse with all different kinds of different species and ages of trees growing in different ways. And so that's one way that we're reacting to it. We're actually hoping to get a project going with Tony D'Amato from UVM, who's an amazing forest scientist, at the Catamount Community Forest in Williston, where we're going to be doing, in addition to some climate adaptive forestry, where we're creating intentionally driving disturbances through cutting trees and logging in a very specific way, also doing some underplanting of species that we expect to be more common as our climate changes. So I guess that's not a very good concrete answer for you, but the answer is that we're trying lots of different stuff. And that in general, you know, I am on a landscape scale favoring some of these southern adapted species, but I'm not going and cutting every sugar maple, because in 80 years, we're not going to be in a good place for growing sugar maple anymore. It's much more of a slower walk than that, I guess.
So with that in mind, someone asked about ash borer, and kind of the ash borer relates to that same answer. So if you just sort of want to tweak it a little for ash borer, that'd be great.
Yeah. So the emerald ash borer is in Vermont. I don't have off the top of my head how many different occurrences we have in Vermont, but several in pretty much every different part of the state. We're at the 33rd or the 34th state in the country that has it. It's a exotic invasive insect from Asia that basically kills almost all of our native ash trees. And so we expect mortality. You know, we have some differences in studies, but just most of our ash trees are going to die from infestation of emerald ash borer, and that's of all three of our native ash species. So that's white ash, green ash, and black ash. Statewide, ash trees are about 5% of our total stocking, but locally they can be much more abundant, like 20+% in Grand Isle County. You know, I think there are stands with 40 or 50% ash. And so the way we're managing for that, again, it's nuanced. We don't want to just go and cut every ash tree, because what we would do then is we would miss out on any chance that some of those ash trees will be resistant. And we know that there is some resistance. It's low, but there are some trees that seem to be able to combat emerald ash borer. And like beech, we want to grow. We don't want to lose species of trees. We want to grow healthy, resistant trees that are going to be able to combat these human-created problems. And so what I'm doing in many cases is strategically harvesting to create opportunities for actually regenerating ash, leaving a lot of big ash for seed sources, harvesting some ash in some cases to capture the value in those trees before they die. In a forest context, that's what we do. In a residential or a municipal context, it's way more complicated, because those are trees that are over power lines and they're in our yards. And so that's why you've seen some of the towns in Vermont and across New England proactively cutting those ash trees, because there are so many of them. And this is something that's happening, and we just have to get ahead of it before it becomes a bigger problem than it already is.
Great. Well, we're over our time, Ethan, and people are starting to sign off. So I think we're going to thank everybody for joining us tonight.